Welcome back. The video today is all about parallel lines and special angle measures. Let's talk about the corresponding angles postulate first. Here's what it says. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So you have to know that the two lines are parallel first. So in this figure, you have to be given that line L is parallel to line M. Now we can conclude that any pair of corresponding angles is congruent. Using the vocabulary from yesterday, I know that one pair of corresponding angles is angle 2 and angle 6. So for example, I could conclude that angle 2 must be congruent to angle 6. Similarly, it works for any pair of corresponding angles. So, angle 3 must be congruent to angle 7. Now think about this. Angle 2 and angle 4, these are vertical angles. We already know angle 2 and angle 4 are congruent. Now we also know angle 4 must be congruent to angle 8 because they are corresponding angles. I know that angle 2, 4, 6, and 8 all have the same measure. They're all congruent to one another. Finally, the last pair is angle 1 congruent to angle 3. Now let's try to use this in a problem. It says in the figure, the measure of angle 5 equals 72. So I will always start with labeling what I'm given. It says find the measure of each angle listed below. Now I'm looking for the measure of angle 4. Angle 4 and angle 5 are corresponding angles. So I know that angle 4 must be congruent to angle 5 by the theorem I just learned, corresponding angles postulate. Now I know that their measures must be equal because that's the definition of congruent angles. So, I can conclude that the measure of angle 4 must be equal to 72 by substitution. This is not a proof. Note that this is not a proof because you are not given the answer. You're just showing out your reason for each step. Okay, next it says find angle 2. So we're finding the measure of angle 2. I know angle 4 and angle 2 must be congruent because they are vertical angles. So I can say angle 2 is congruent to angle 4 by vertical angles theorem. Now I know that their measures must be equal by the definition of congruent angles. I can substitute in the measure of angle 4 that I found above to get the measure of angle 2 equals 72. Pause the video and try the practice problem below. Alright, next let's go to the next page. We have similar theorems for different angle pairs. We have another theorem called alternate interior angles theorem. This says that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. For all three of these theorems, you must first be given that the two lines are parallel. In this case, for alternate interior angles, one example would be angle 2 must be congruent to angle 7. You could also conclude angle 3 must be congruent to angle 8. Now let's look at consecutive interior angles theorem. This says that if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So this goes back, we still know that the two lines have to be parallel in order for this to work. And we can conclude that angle 2 and angle 8 must be supplementary could also say angle 3 and angle 7 must be supplementary. Remember, in both cases, this means that the measures of the angles add up to 180. I want you to think about this. We already know that angle 7 and angle 5 are congruent based on the fact that they are vertical angles. I know angle 5, 7, and 2 are all the same measure. I know these alternate interior angles 2 and 7, we just learned those have to be congruent. So, if I'm looking at angle 5 and angle 8, I know those have to add up to 180. So if 5 and 2 are the same thing, wouldn't 8 and 2 also have to add up to 180? That's where this theorem comes from. Next, let's look at the alternate exterior angles theorem. This says that if two parallel lines are cut by a transversal, so we have to be given this first, then each pair of alternate exterior angles is congruent. So, for example, angle 1 must be congruent to angle 6. This is similar to what we just talked about. Angle 1 and angle 3 are vertical angles. Angle 8 and angle 6 are vertical angles. We already know 3 and 8 are the same. We already know 8 and 6 are the same. We know 3 and 1 are the same. That means 1 and 6 must also be the same. Similarly, I know angle 4 and angle 2 are congruent based on vertical angles. I know angle 2 is congruent to angle 7 based on alternate interior angles theorem. And I know angle 7 is congruent to angle 5 based on vertical angles theorem. Therefore, by transitive property, I can say that angle 4 is congruent to angle 5. That's where this theorem comes from. Alternate exterior angles must be congruent. Let's try using these to find angle measurements with algebra. So sometimes they won't always just be straight up find the number. Sometimes you'll have to set up an equation and solve it using algebra. So let's see if we can do this. It says use the figure at the right to find the indicated variable. Explain your reasoning to set up the equation. So let's look at these two angles. Right now, angle 1 and angle 4, these do not have a special relationship. It won't always be super easy where they're just going to give you it right away. However, I do know that angle 2 and angle 4 must be corresponding angles. They must be congruent. So let's jot that down first. I know angle 2 is congruent to angle 4 by the corresponding angles postulate. Next, I know that means they have to have the same angle measure. That's the definition of what a congruent angle is. Now I also know that angle 1 and angle 2 form a linear pair. Therefore, they must be supplementary. So I know the measure of angle 1 plus the measure of angle 2 has to be equal to 180. That's linear pair theorem and also the definition of supplementary. Now, since I know angle 2 and angle 4 are the same thing, I could say that angle 1 plus angle 4 would also have to equal 180. If it helps you, you could write 2x minus 17 here because I know that angle 2 and angle 4 are congruent. That's just called substitution. Now, in order to solve for the variable, I'll need to plug in my expression for each angle. I know angle 1 is 85, and I know angle 4 is 2x minus 17. I trust that you know how to use your properties of equality by now. So in this chapter, I'm not going to make you write out every step, such as addition property of equality, subtraction property of equality, etc., you can just go ahead, once you have the equation set up with the x values in there, once you have it with an x in it, and it just looks like algebra 1, once you get to the step where it's just algebra, you can go ahead and solve it without doing all your work and justifying every reason. You obviously still have to show all your work. 85 minus 17, that combines to give you positive 68. Those are like terms. Next, we can subtract 68 on both sides to get 2x equals 112. And finally, divide both sides by 2 to get x equals 51. Let's do another. This says find y if the measure of angle 3 is 4y minus or plus 30 and the measure of angle 7 is 7y plus 6. I know that angle 3 and angle 7 must be congruent because they are alternate interior angles. So I'll write that down first. Remember, feel free to abbreviate here. I know that that means they have to have the same angle measure. Therefore, 4y plus 30 has to be equal to 7y plus 6. Now that we have the algebra equation set up, you can go ahead and solve it without showing every justification. So first, subtract 4y on both sides. Next, subtract 6 on both sides. Now you can get y by itself by dividing both sides by 3. And you get y equals 8. You could double check this answer by plugging them back into the expressions and make sure that they're equal for angle 3 and angle 7. And try the practice problem on your own below, A and B. Here's the correct answer for A. Those are alternate exterior angles. And for B, I'd like you to find the answer on your own. Before I leave you today, I would like to tell you the perpendicular transversal theorem. It says that any plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other line. So for example, if we know that line A is parallel to line B, which is shown, remember, by these symbols here, and you also know line A is perpendicular to line T, shown by this right angle symbol here, then you can conclude that the transversal must also be perpendicular to the other line that is the parallel lines. So we can conclude that T must be parallel to B. Finally, I'd like you to reflect on this question. What do corresponding angles postulate, alternate interior angles theorem, consecutive interior angles theorem, and alternate exterior angles theorem have in common? What makes them different? Compare and contrast them in 2 to 3 complete sentences. Have a great night.